Chemistry. Welcome back. We left off the other day, yesterday, A-Day. A-Day? Yeah, A-Day. We left off A-Day with average atomic mass. That equation down there in the bottom left of the screen. Pretty sure it's bottom left for you. An equation that you kind of have to know how to use, especially because this has no backup, right? This is only kind of in your head. It's not on the reference table. I had a few questions for y'all to look at. I have copies of them over here. I had you do 13, 14, 16, and then all these short answers. I'm going to go through them pretty quickly here. So if we're looking at this, average atomic mass is the weighted average of, and I tried to have you underline this, naturally occurring isotopes. That's choice 3, straight up definition. Number 14, sorry, we have two isotopes. Here's a percentage and a mass. Here's a percentage and a mass. I guess let me label it differently. Let me say that those two are circled, these two are. So I should have 72 plus 98.9. For starters, I don't even know where this number came from, so that is out. 72 minus 84.9. Okay, again, it's not, we have to multiply them. I know I have to multiply them. And because it's a percentage, we have to divide by 100, but we said that if you turn the percentage into a decimal, you don't need to worry about it. There's choice 3 again. And finally, I need this to be a mass of chlorine. It's 35.5. What mixture, shown as percents, would produce the mass? Well, I can eliminate these two right away. The reason I can eliminate those two right away is because they're not even the right element. Those are carbon, not chlorine. It's 35.5, which means it should be closer to 35. So if my options are 35 and 37, it can't be 50-50. It has to be skewed more towards chlorine 35, 75% chlorine 35. Alright. Number 33 says, in terms of atomic particles. Alright, see that? So you have to mention atomic particles. You could say different number of neutrons, and that's the only option. 34. Look at this. Show a correct numerical setup. They don't even need you to solve. They just need you to set it up. 0.909, there's my abundance, times 19.99 plus 0.003 times 20.99 plus 0.088 times 21.99. There's my setup. And then based on the abundance, what's it closest to? Well, I have this 90.99, so it's closest to neon 20. Right? And this should look basically just like what we did here, other than this number 33. 36 and 37, more of the same. We have one piece of information, we have second piece of information, so 0.9893 times 12 plus 0.0107 times 13. There's the setup. In terms of subatomic particles in the nucleus, difference and similarity, and include both isotopes. Okay. Carbon 12 and carbon 13 have same protons but different neutrons. There it is. Again, just talking about isotopes, right? The existence of isotopes is why we have this average atomic mass. A little bit of review. But those were those questions. I hope those were fairly straightforward. They should have been fairly straightforward. We left off right here with this example, the top of 35. Excuse me. I'm going to pick up kind of in the middle. Ooh, hello. There we go. So we have this 4-part title, but I'm going to tell you right now that this is the version of the title that comes up most frequently. The gram formula mass, or GFM, which is how I will usually talk about it. So GFM is simply the sum of all the masses of all the atoms in any given compound. That's it. Just add them together. And when I say the sum of the masses of the atoms in a given compound, this is like, look at the reference table, look in that top left corner, figure out what it is to the nearest whole number, add them together. So the mass of O2 is 16. This is from the reference table. There are 2 oxygens, so I'm going to multiply 16 times 2 is 32. If I was going to do the formula mass for NH3, I would need the mass of N, which is 14, right? And there's 1 nitrogen. I'm going to add that to the mass of hydrogen, which is 1, and there are 3 of them, which is 14 plus 3, which is 17. Now, the units are a bit funny. I can use atomic mass units, or I can use grams. I will tell you that much more frequently you will use grams, right? It just happens to be a lot more frequent. Now, a few examples here. There are many more examples on the next page. I'm not going to go through all of them right in this moment. I'm going to save them for a bit of review in the near future. Formula mass for the following. Take a minute, try to do these. Like, pause the video, you get your reference table, try to find the GFM, the mass for all these, right? It's what's the mass of that element times how many there are, plus what's the mass of the next element times how many there are, plus, just keep going. I'll give you a second. Hey, guessing you're back. Okay. So here, the mass of hydrogen is 1, and there are 2 of them, plus the mass of oxygen is 16, and there's 1 of them. That's 2 plus 16, that's 18. Here, Na has a mass of 23, and there are 3 of them, plus phosphorus has a mass of 31, there's 1 of them, plus oxygen has a mass of 16, there are 4 of them, which is 69 plus 31 plus 64, which is 164. Finally, the mass of carbon is 12 times 6 of them. The mass of hydrogen is 1 times 12 of them. The mass of oxygen is 16 times 6 of them, which is 72 plus 12 plus 96. And that gives us a grand total of 180. I think the harder part here is making sure to remember how to count, right? If you have parentheses and a subscript, distribute first, then you can do your counting. Again, like I said, I'm leaving this page alone. If you want to do this as extra practice for yourself, please feel free to. Otherwise, here we go. This is the last bit of our little mini section. This is the last bit of notes. The percent composition by mass. Now, one thing that you will need to write in here, there should be a line here, because this is an equation. It should say percent composition equals the mass of the part divided by the mass of the whole times 100. And really, this is a percent. Right? This is on your reference table. So you don't need to memorize it, but you need to recognize when to use it. Right? If you want to find the percent composition, then the mass of the part is equal to the total mass of that element. So if I'm looking for the percent composition of oxygen, then I have to count all the oxygens. What's the total mass of all the oxygens? And then over the mass of the entire compound. Right? So that's the mass of the whole. That's the whole thing. Right? So if I'm doing the percent percent composition by mass, these two phrases mean the same thing. So just as like note to self, I'm boxing it in. So I'm looking for O in CuSO4, right? So they find the total mass. This is copper, here's sulfur, and here are my 1, 2, 3, 4 oxygens. So this is the total, or the whole. This is the part, which is why it's 64 over 160. So I have this decimal place. and then make sure to multiply by 100. That's how we got to 40%. It's okay in this case, round to the nearest percentage, like the nearest whole percentage, and that's fine. All right. Oh, hello? Hello? Uh-oh. There we go. All right, we're good. Now, there are some practice percent composition questions. There are 4 of them. There are 3 on this page. There's 1 on the next page. The problem is, these are names, not formulas. Little reminder of how to make the formula from the name. Right? Both of these are poly, so check table E. Ammonium is NH4 with a +1 charge. Sulfite is SO3 with a -2 charge. Which means if I'm going to combine these, I'm going to put these together, I'm going to do my shortcut, so this goes here, that goes there. So I have NH4 parentheses 2 SO3, there's ammonium sulfate. Right? This time, this is a poly, but aluminum is just Al with a +3 charge. I checked the reference table. Acetate is C2H3O2. It has a -1 charge. So again, I'm going to crisscross. That means I have Al C2H3O2 with a 3. Sodium is just Na with a +1. Bromide means Br with a -1, which means this one is nice. It's just NaBr. And last but not least is at the top. Oh, there we go. Top of the next page. Copper 2 hydroxide. Now, a little star next to hydroxide. It ends in IDE, but it's a poly, so check table E. Copper 2 means copper with a charge of +2. Hydroxide on table E is OH with a -1 charge, which means that this guy is CuOH2. Now, I did the formulas so that we could actually do the masses, because we need to know the formula in order to set this up. In order to do mass of the part divided by the mass of the whole. Don't do that. I want to move this. There we go. So if I'm going to do this, right, this is mass of the part divided by the mass of the whole thing times 100%. Which means here, if I'm looking for the percentage of nitrogen, then I have to do, how much nitrogen is there? Well, this 2, this is what I meant, right, if you remember. This 2 distributes, so there are actually 2 ends, and nitrogen has a mass of 14, which means this is 28 over, right, I need the mass of the whole thing. Well, the mass of the whole thing is going to be 2 ends, that's 28, plus 8 H's, that's plus 8. 1 S has a mass of 32. And 3 O's has a mass of 48. And you'll see why I did that breakdown in a moment. All of that added together equals 116. So I have to do 28 divided by 116 times 100%. And if I do that, I get 24%. So the percentage for N is 24%. If I want to do it for H, I need to do, that 8 that I put down there, that's the mass of the H. So I have 8 over, the mass of the whole thing didn't change, guys. I'm just going to multiply by 100%, and I do that, I get 7%. For sulfur, I'm going to do 32 divided by 116 times 100%. And I'm going to get 27%, I believe. Should be now, must be 28%. Yeah, 28%. My apologies. I'm doing this off of a bit of memory. I remember I did this a few times today. So 28%. Then here, if I do this, I have 48 over 116. And that's times 100%. And that's going to give me 41 I believe, because half of this would be 58. So 48 is a little, yeah, 41%. Now, if I add all these together, I should get 100%. So 24 and 7 is 31%. 31 and 28 is 59%. 59 and 41 is 100%. So this is kind of like the process, right? This is the process by which to go and do this. If you want more practice with obvious answers, you can do these. However, I am also going to give you more questions out of the review book, that orange book. They are posted on my CBA. If you can't, again, if you really can't find your orange book, one, you should really try to get on that and find your orange book. But two, I did post pictures of the questions again. The questions are listed on there. Make sure to upload that to my CBA. I gotta check those directions and make sure that I've said I want you to upload those to my CBA. On C-Day, what I'm going to do is start a lab. I'll do the same thing. I'll make a little video of the procedure really quickly, and then we will be able to, or you will be able to do those questions on your own. There's a small change in how I'm going to do the quiz. The quiz for this information, and by the way, this information is pages 34, starting with the average atomic mass, going out to the notes here on page 37, the percent composition by mass. The reason I'm not doing anything with the percent water in a hydrate, this is the lab. So I'm going to use the lab to explain this. It's not super different. The only difference here is instead of looking for an individual element, I'm going to use water as my part. All right, so it's really the same thing. So what I'm going to do, the quiz for this, rather than doing it on the in-person D day, which would be Tuesday, Wednesday of next week, what I'm going to do is I'm going to open it up on C2 day. Group 1 students, you are going to take this quiz, or, it'll be open to you to take on C2 day. Group 2 students, the quiz will stay open until D1 day, right? So by the end of the school day, D1 day, so about 3 o'clock, the quiz will close. You have to take it in that time period. It's going to be on my CBA. So it's one of the ones where the multiple choice and short answer is already on my CBA. You punch in your answers, you can get feedback pretty quickly. It's much easier for me to grade, and it saves me a little bit of time as far as class days, right? So it's going to be an online quiz. It's going to be on my CBA. It'll be on C2 and D1 day, right? You'll see more information soon online. I can't make that go live too quickly, otherwise it's already open. But just as a small change to the schedule, all right? Now, I don't want to go on too much longer. I've already gone well past my 15 minutes. I will see you on C-Day, where we will get the lab started. In the meantime, be good. Stay safe, kids. Take care of yourselves.